Good morning, everyone. Welcome to this session of livepatching Linux in Debian. The presenters will be Santiago and Emmanuel. Give them a very warm welcome applause.
Hello, everybody. Thank you to come here. Well, we want to talk about livepatching Linux in Debian. That is something that we started to thinking some months ago. What is livepatching? There are some situations where users need to avoid rebooting the system. For instance, if they are running complex scientist computations, services downtime need to be minimized, for instance, or the most important part or the most important thing is if the user is watching a very long video of cats. So we don't want to reboot the system in that case. So, but we want to have an updated and a secure kernel. So light patches make it possible to apply some security fixes into the kernel without waiting for the reboot of the system. Light patching in Debian, maybe we asked some months ago, but we don't want to give more work to the Debian teams, so we are just trying to do something. So we are starting to look in the state of the art. We can note that there are some distributions that already have live patching services. For instance, Ubuntu, high or critical vulnerability are detected and then create live patches. All the patches are tested in the canonical servers. When the patches are ready to be distributed to the users, they just send a notification and the user can install the patches. For Red Hat, we don't have too much details. Light patches, we know that light patches are distributed as kernel modules in RPM packages. For SUSE, also like a Red Hat, we don't have too much detail, but they are based in kgraft. For Gentoo distributions, they was working in livepatch. That is a service, server-client architecture. The client sent a request asking for a light patch to the server with a patch or asking for a CVE patch, and the server built that patch and return back to the client. The server used kpatch. The only thing that we need to mention here is the livepatch. Seems to be doesn't have too much work in the last time. So, well, that is something that we need to consider. For this, we can say that there are no community-based distributions. It's provided Linux light patches. And maybe because, or I know that's the reason, but it's not an easy task. The other thing that we need to consider is that in the mainline kernel there are some light patch modules. Light patch module allows us to create zip files that modify some kernel functions, and with this module we can generate kernel modules. And this requires adapting patches to the light patch structure, so this cannot be an easy work. The other tool that we are looking is kpatch. Kpatch is an interesting tool. We can go from a divpatch file and then create a module kernel from the patch file. This saves us time, and we can just use a diff file, for instance, this, And we use this as an input of kpatch, and kpatch generate the kernel modules. No, if you.
Well, as Emmanuel said, we are considering kpatch that uses a feature of modern kernels, actually since the kernel 4.0, this function has been used, or is being used for tracing. So what it does is the compiler injects a no-op at the beginning of the function, and that function can be replacing during runtime to call the tracing facilities. So livepatch replaces the function in the kernel, registering an ftrace handler to modify the return of the function. Regarding kpatch, we have recently uploaded the most recent release from upstream. So the kpatch 0.99-1 was uploaded some weeks ago, and it will be probably transition to testing tomorrow or after tomorrow. I don't remember exactly, but just to have to say that the status of kpatch is good now. There are no RC bugs currently. So this summarizes what I just said. Before patching, the function returns its normal operation, and after patching, the ftrace facilities redirect the functions to the replacement function. So it seems simple, but we will see. Of course, there are some restrictions regarding the implementation that we are looking for. We are not thinking in supporting secure boot, at least at the first time. This could be probably solved by Debian, the framework, the facilities that are being developed by Friction, because they are already supporting the assigning service for secure boot. kpatch supports 3 architectures. For the beginning, we are probably considering only AMD64. We will see for the other 2. It is more when a patch needs to change the data structure, the things becomes more complicated, and there are also some restrictions when the init code for drivers needs to be changed. There are other restrictions regarding removing references or static local variables. And it's important to say that while kpatch makes the life easier, it doesn't guarantee that all patches can be safely applied. And human, well, at least for the moment, needs to analyze every single patch. Want to say this or okay? Yeah. We have been considering 2 approaches to build and distribute the live patches in Debian. One is by Debian packages. It seems has been done by Red Hat, and the other through a client-server architecture. There are pros and cons for both. Via Debian packages, we could say that we can rely on the existing infra, on the tooling, especially in the caching facilities and all the mirroring. The tools also exist for building, distributing, and for installing the packages in the user's machine, of course. Regarding the cons, probably there is a slower distribution than in a client-server architecture, but it is not really a strong argument. We have tried some attempts for this, and we have already faced some complications, especially because kpatch, for example, requires the full source code of the target Linux for which we are building a kernel, and it means that if we are supporting 10 kernels, we will need the source code for 10 kernels in a source package, which is not a very good idea. there is a proof of concept in this repo. The other approach will be a client-server architecture. Regarding the pros, in theory, it could be faster and easier distribution compared to Debian packages, but again, we are not sure of that. And the cons is that we need to build all the infra and the tools because everything is not existent for the moment.
Well, I talk about livepatch lifecycle. We can have four states when they are loading and enabled. The only way to load or enable a patch is during the loading process. That happens when we call the klp enable patch functions in the module init callback. We have to know that the relevant information or entries are created in sys kernel livepatch and the name of the patch. And the transitions are writing in the transitions file. And when the transition starts happen, is set number 1 in this file. And then when all happen and all finish, the transitions change to 0. In the other state, the replacing all patches can be replacing if they have the replace flag set. Well, when the new patch is enabled and the transition finish, all functions are replaced are removed. Then we have two more states, disabling and removing. For disable, we just, the livepatch module just write a 0 in the enable file. For removing, it's only safe when the all functions in the are not user. It's only safe when there are no user of functions provided by the module. If you want to read a little bit more about this, this is the URL for the resources for this.
So we need to consider what will be the life cycle of live patches in Debian. And the main question will be for how many times we are going to support the specific live patch, or a specific kernel actually. So this is just a part of the of a set of kernel updates published by the security team. So we consider, for example, the updates that have been done since beginning December last year, the middle of June. In average, there are one release per month, more or less. And we will need to consider if we are going to support the security live patches for every one of those. We don't have an answer for that yet. There are also other things to design and define it. Well, we have already mentioned the life cycle. How to integrate new patches, we are going to mention this in the following slides. We need to collaborate with other teams, especially the security and the kernel teams, how we are going to handle embargoed patches, for example. The CI is something that is very important, and we don't know yet how to do it. We could use also CI, but not in the shared runner, because we will need access to the kernel for sure. And we need to properly define the whole workflow. What's next? So this is, as you see, this is in the very early stages, and we are open to listen opinions, how to define the architecture and the workflow. So we would like to say that we are open to this, to listen to your opinion. And we are looking for help. So time for a live patching live demo. We have a couple of demos for this. Spoiler. So yeah, just let me. I have a. Probably you have already seen. I have a spoiler again. We have. Yeah, sure. Like this. There is already a model enabled. It's a model that patches the CMD line. Let's start by disabling it. So I have just disabled a live patch that was enabled in start. Let's check again the list. There are no patches loaded, and let's take a look to the arguments that were passed to the kernel at boot time. So I intentionally boot my machine with not the latest kernel available currently in Debian stable. This is 6190, if I'm not wrong. And now I have this couple of models here, and let's load this one. This is loading. It's waiting for the transition to complete. Let's print again the CMD line, and we have a nice code, super code. So this is the version of the hello world for live patching. And let me show you that using key patches is very simple, because we only need the very actual patch to build it and load it. If you look at the kernel source code, there are some samples doing similar things, and this is the equivalent. This is the equivalent example that you can find in samples, livepatch, sample if you're curious, and you need to add some structs and find some macros and etc. So KeyPatch really makes the life for this much easier. So we have a second example here for the CV 2024-36917 that was an overflow when disabling block devices. And this is the sorry, it's already open somewhere. So this is the patch that fixes this vulnerability. We have already built it with KeyPatch, so it's a simple patch actually. Now we can just disable or CMD line live patch, and we can load. This is an error here. Can find. Yes, sorry, wrong directory. Nope, again. Yeah, sorry. And the patch has been applied. Sorry, I don't have a proof of concept of this patch, but believe me, the security vulnerability has been fixed. One of the questions or the things to consider was how to track the security availabilities in kernel, and we would like to mention that the kernel and the security team do a great job tracking every CVE, especially now that the kernel publishes or assigns a CVE for every bug. So this is, and they track this in the kernel repository. For example, there is these vulnerabilities in the Active Directory, and we can track the commit that fixed the vulnerability in the 6.1 branch that was fixed by this commit. So I got information where to handle, where to get the patch from this repository, and if possible, we would like to contribute to keep tracking of the commits of the security vulnerabilities and the commits that fix them. And that's it.
Yeah.
Thank you very much for attending. Questions?
Hello, thanks for the great work. This is much appreciated, especially for people using servers where rebooting is complicated. You mentioned that you don't have secure boot support. Is it because the kernel modules needs to be signed? The one that the .ko files that you load, if they were signed, would it be okay?
Yeah, they need to be signed.
Then, therefore, if I use a mock key, a machine owner key, does it work?
Probably, but I think there is already a solution that needs some time. As I mentioned, the Debian is providing a signing service for secure boot. This is not done yet, but probably we could use that. So this is a restriction for the beginning. So we are not considering secure boot at the beginning of the work, but potentially we could have signed modules.
Thank you. So just from my perspective, using a machine owner key is already very good.
In theory, yeah.
To apply live patching for a CVE in an inline function, would it be sufficient to modify the CVE patches likely to account for the inline function? Because I understand the trace points that can be hooked with a no payload are available at function entry and return points. So if a CVE vulnerability occurs in an inline function, how should live patching be performed?
You like to answer?
No.
Okay. I don't know exactly. We'll have to dig on it. But if you have an answer, you're also welcome to contribute. But I don't have an answer right now. We don't have an answer right now. But we can, if it's important for you, we can dig on this topic.
Thank you so much.
Hello.
Hello.
The short question is, are your architecture restrictions those of ftrace, or do you have additional constraints?
We cannot hear. Could you please?
Oh, so the architecture restrictions that you mentioned, do they come from ftrace, or there are other constraints for live patching besides those of ftrace?
As far as I understand, they come from the kernel and from keypatch. So keypatch, for example, doesn't support ARM64, so they come from them.
Okay, thank you.
Hi, thank you. Because of the operational overhead involved in producing a live patch for the kernel, you're going to be limited in terms of which CVEs you'll be able to live patch. And because of that, I would propose that you limit yourself to CVEs that are either for which there's already an active exploit available, or for which there is likely to become one in the near future. And also, in order to avoid providing sort of a false sense of security for people, it's probably a good idea to be very clear about exactly which, how you evaluate CVEs and which kernels are going to be supported, and probably don't support very old ones, right? Because the older the kernel, the more unpatchable, unlive-patchable CVEs there are going to be. So there's a possibility of a false sense of security with this, and it's just important to keep that in mind with
of course.
This sort of how we document this service and this functionality.
Yeah, we didn't mention that, but yeah, we need to be clear how to triage the CVEs, what kind of CVEs we are considering, because it's simply not possible to apply all the open CVEs. Yeah, of course.
Thank you for your presentation. Can the livepatching apply the multiple kernel livepatches, or only there can be some restriction, like after livepatching one patches, another patch cannot be applied?
Would you like to answer? I didn't understand very well the question. Could you repeat that, please? Sorry.
Does it can it apply multiple live patches on
multiple?
Multiple.
Yes. Sorry. Is it possible? Personally, I have not done much test on this. I tried, but I haven't had the time. Is it possible to apply patches, multiple patches? Yes. That's something that will be needed if you need to fix multiple security vulnerabilities. Sorry?
Cumulative.
Yeah, cumulative. So at the beginning of the support of live patching in the kernel, the patches had to be cumulative. And very recently, I don't remember exactly what from which version, but now there is atomic replacement too. So yes, to answer shortly the question, yes, is it possible? But personally, I have not tried it yet.
I see.
KeyPatch has an option to apply some flags to allow the replacement and apply cumulative patches. Yep.
Okay, thank you.
Hello, thank you for your presentation. I suppose that when we compile a live patch, we need to compile with the same optimization flags that we compiled the kernel. So I was wondering, how do you plan to do this kind of synchronization between the packages with the kernel Debian package?
Would you like to answer?
I think that maybe we use the config file.
Yeah, actually, the Debian kernel packages come from a config, from the config, so we need to synchronize with them. That's not the most difficult part, I think.
Yeah.
Because the config files are available in the Debian kernel packages.
And also, kpatch check for the GCC compiler that is the same as in kernel user.
I have a small question. I just want to know, is there any limitation or restriction for live patch? I heard a limitation about the CPU architecture. I mean that, is there any functions that could not be live patched or not?
I don't know. I haven't seen the differences in different architectures. No. We don't know yet.
Oh, okay, thanks.
Okay. How do you identify the running kernel? before patching it or trying to patch it? What is the signature of the kernel which you use for this?
Before what you say, sorry?
Before trying to patch it. Is this mod versions only or something else?
I think KeyPatch tries to do so. There are different things. The one is building the model, and the other one is applying it. And if I'm not wrong, KeyPatch handles that. And there are some bugs, actually. There are some bugs in the way how KeyPatch identifies the running kernel and the signature that we use in Debian. And I will need to check that, because I see the bug just coming to the presentation. So I will need some time to give you a more precise answer and to fix the bug.
Okay, thank you.
The secure boot is not yet this livepatch system. Do you have a plan for secure boot or a secure boot system?
Could you repeat that, please? Sorry.
Secure boot.
Again? Yeah, the question is, what are the plans for secure boot? Is that?
Yes.
So as we mentioned, probably the path to follow is to use the Debian. There is a great tool being developed currently called Debian that has a service that provides signing for secure boot. That's what we probably will, based on as far as I understand, the service is done for signing the Debian packages, use it, the kernel and Groove, etc. And we will need to adapt it for kernel models.
Oh, okay, thank you.
But this is not our first priority.
There's a question from IRC, from Nodens. He asks, what kind of help do you need first? Is there a specific team we can join?
Do you want to say something?
I don't know, maybe we have a lot of points to start contributing. One of them is if we want to go to the service side, maybe we need to define that. This is one of the points. I don't know if you want to mention.
I do agree.
Yeah.
I didn't want to answer first because I wanted to be sure of your point of view. But I think the first or the next step is to design the client server architecture for this. Regarding the specific team, no, we have a couple of repos, but the repo of KeyPatch and the livepatching repo, and they are in the Debian namespace. But this is for the code. Probably we could create some infrastructure for the teams.
The matrix.
Yeah, we have a matrix channel. Yeah, we could create a matrix channel for that.
So it seems there's no more questions around. If there's any, you can always come up to Santiago and Emmanuel. And thank you for the attention, all your questions. The next session will be at 11 here. Thank you for attending. Bye.
Thanks.